Hi, whoever's grading this is project 3, and this is our board and the setup. And so if we look up here, we have a constant DC voltage, 720 millivolts, 0.72 volts. And we come look over here on our multimeter, we're at a 0.73 volts. That's fairly accurate, that's within spec. And so we're gonna move up, move up, move up, move up, move up. We're gonna try and make our way to the max voltage setting here. You know, take our sweet time with it. And really pay attention to the offset as I bring this up. We'll see real time changes. We're at 2.5 volts here. And if we look down, we see 2.5 volts and about 2.54. So there's a little bit of variation, but it's still pretty accurate. And now to bring us to the next test case, we're going to be doing a sine wave with 1.5 volt DC offset at 500 hertz. 3 volts peak to peak. 1.5 volts DC offset 500 hertz. So let's go to our sine wave, get our frequency down to 500 hertz, and we'll change our amplitude, our offset to be 1.5. We'll pull this down so you guys can actually see it, and our amplitude will be 3 volts peak to peak. Oh, that's not 3 volts peak to peak. And if you look on our screen, we'll see peak to peak voltage at 3 volts, DC voltage offset pretty close at 1.52, and true RMS at 1.89 volts. Now to move on to the next test case, we're going to be looking at a 1 volt peak to peak sine wave with a half volt DC offset at 1 kilohertz. So we'll bring this down to 1 volt real quick. Our trigger's terrible, so you know, that's okay. And I'll bring our offset down to half a volt. And this is where everything's gonna get real slow, because you know, we're in millivolts now, guys. And now if you take a look at our screen here, oh, frequency needs to be at a kilohertz. Gotta make sure that's a little high. And we take a look, we're at 998 hertz. Voltage peak to peak is 1 volt. True RMS is about 0.63 volts, and DC voltage is half a volt. That's pretty close. And now we're gonna move up to 1 volt peak to peak at 2.5 volts DC offset. So let's get all our way up to 2.5 volts right here. And trigger this. So if we take a look, and now we'll take a look down here. We see that our true RMS is 2.57 volts, DC voltage is 2.54, and our peak to peak voltage is very close to a volt, which is all great. And now we're gonna be working with our favorite triangle waves. So let's go to a 3 volt peak to peak triangle wave. 3 volt peak to peak triangle wave at 50 hertz and a 1.5 volt DC offset. So at this point, we're going to be running into difficulties because we're going to be going to very low frequencies, and our timer overflow doesn't work very well, and so we can't really we find it very difficult to measure these. And so this is 3 volt peak to peak at a half volt DC offset. So let me change this down to half volt DC offset and 3 volt. Right, and so here we can see the frequency starting to bug out, but we have the correct peak to peak voltage as well as the correct true RMS and DC voltage. Very nice. And now we're gonna move to 10 hertz, and this is again very, very disastrous for our frequency, because for some reason our timer overflow is terrible and we've been struggling. That's okay. And here we'll see, wait, do we have the right? We need to make this down 1 volt peak to peak. So let me bring this down 1 volt peak to peak and change the offset to 1.5 volts. Here we see that we run into some issues with the frequency, and at such a low frequency it starts to really affect the rest of our functions, and that's okay. we're going to move on to a 3 volt peak to peak sine wave at 1.5 volts at 1 kilohertz. So we're going to change this off. We're going to change this amplitude back to 3 volts. Change this to a sine wave, and we'll change our frequency to 1 kilohertz, which you will see matches our spec. As we can see right there, frequency is at a kilohertz. And now if we go down to a square wave at 1 hertz, we're going to see that it does not meet spec and in fact breaks. At way before 1 hertz, at about 1 hertz, here we are. It's broken, but we have our DC voltage, our true RMS, and our that is the voltage peak to peak, the DC voltage, and the true RMS. Thank you.